Assalamualaikum and a very good day everyone. Let's try some question from the topic basis and dimension. So S equal to this set is a basis of V if and only if it satisfies two conditions. Number one, if S is linearly independent, and the second condition if S spans V. V here is for vector. We can also check for matrix and polynomial. Okay, the first question is for polynomial. So we want to test if the set S is linearly independent and if the set S form a basis for P2. Okay, these two question is continuous because in order for us to determine basis, we need to make sure that the set is linearly independent and spans. Okay, it must satisfy these two conditions first. Let's discuss the question. So we are given a set of polynomial S equal 2 plus x, x plus 2x square, and 4 plus 2x square. And then to prove for linear independent, multiply by a scalar. And this should equal to 0 for constant, 0x and 0x square. For constant, for x and for x square. Okay, constant we have 2c1 and 4c3. So 2c1 plus 4c3. For x we have c1, c2. Okay, so c1 plus c2. For x square we have 2c2 and 2c3. So 2c2 plus 2c3 equal to 0, equal to 0, equal to 0. Okay, and then we can change this into matrix form. Okay, 2c1 plus 4c3, so we don't have c2, 2, 0, 4. C1, C2, we don't have C3, 1, 1, 0. And from the last line, 2C2 plus 2C3, so we don't have C1, 0, 2, 2. Okay, since we have a square matrix here, this is matrix 3 by 3, we can solve this by finding the determinant. Okay, let's find the determinant because this is a square matrix 3 by 3. I choose the first column. Okay, the signs are positive, negative, and positive. Positive 2, for 2 we eliminate the first row, so we take 1 0 2 2, 1 0 2 2, and then minus 1, minus 1. This time we will eliminate the second row, so we take 0 4 2 2, 0 4 2 2, but the last one is plus 0, so plus 0, so anything multiplied by 0 will equal to 0. We can ignore that and continue to calculate the determinant. 1 multiplied by 2 2, 2 multiplied by 0 0, 0 multiplied 2 0, 4 multiplied 2 8. So 4 plus 8 equal to 12. So our determinant does not equal to 0. When determinant not equal 0, we can conclude that this set is linearly independent. Okay, because determinant does not equal 0. Okay, that is the first question. Is the set S linearly independent? The answer is yes, correct. S is linearly independent. Then the second question, does the set S form a basis for P2? Okay, we have proved the first condition, linearly independent. We have to prove whether S spans V. Okay, and since for the second question, this is the first question, linearly independent. For the second question, since determinant not equal to 0, the set S spans P3, I believe, P2, because X square spans P2. Okay, therefore set S forms a basis for P2. Okay, because we find the determinant not equal 0, 1, it proved that the set is linearly independent, and it also proved that the set spans at P2. Therefore, set S form a basis for P2. Next question is for matrix. Previous question for polynomial. Determine whether the set K matrices is linearly independent. Then find out if it forms a basis for matrix 2 by 2. Okay, let's test for linearly independent first. The answer is yes. And then test for basis. So from the matrices given, we multiply by a scalar. Scalar C1 multiplied by the first matrix 1 0 1 1 plus C2 multiplied by the second matrix from the set 2 1 1 0 plus third scalar multiplied by the third matrix 1 0 0 1. And to test for linearly independent, this will equal to 0 0 0 0. Okay, let's change into equation for this one. So we have 1 2 1 C1 plus 2C2 plus C3, and then 0 1 0. Okay, ini equal to 0. So we don't have C1, we have C2 equal to 0. Third equation 1 1 0. So C1 plus C2 equals 0, and the last one 1 0 1. C1 plus C3 equal 0. Okay, let's change this into matrix. 1 2 1 0 1 0 1 1 0 1 0 3. Okay, let's test for linearly independent. I want to start by changing this entry. So to change row 3, R1 minus R3. R1 minus R3, 1 minus 1, 0. 2 minus 1, 1. 1 minus 0 is 1. 0 minus 0 is still 0. And then next I want to change this entry. So we want to change row 4. So again I use row 1, R1 minus R4. 1 minus 1, 0. 2 minus 0 is 2. 1 minus 1, 0. And again 0 minus 0 is 0. Let's just copy the entries for row 1 and row 2. Okay, let's continue. Next, I want to change this entry. So we will change row 1 by using the fourth row. So row 1 minus row 4. 1 minus 0 is still 1. 2 minus 2 is 0. 1 minus 0 is still 1. And 0 minus 0 is 0. Next, we change this. So row 3 by using the second row. So row 3 minus row 2. Okay, second row we just copy R3 minus R2. 0 minus 0 is 0. 1 minus 1, 0. 1 minus 0 is 1. 0 minus 0, 0. And copy the fourth row. Okay, from here we can already see that this one is for C1, C2 and C3. Okay, we can continue with one more, I think. Let's change this one. Okay, we want to change R3, R4. We want to make it 0. So R4 minus 2 multiplied by R2. Okay, we want to change R4 only, so we can copy 1, 0, 1, 0, 1, 0, 0, 0, 1, and continue with R4. Okay, R4 multiplied by 2R2 is still 0. R4 multiplied 2 multiplied by 1, so 0. 0 multiplied by 0 is 0. 0 multiplied 0 minus 0 is 0. So from here we get that C1 equal 0, C2 equal 0, and then C3 also equal 0. Okay, trivial solution. Therefore, the set is linearly independent. And then find out if it forms a basis of M matrix 2 by 2. Okay, we have proven that it is linearly independent. Now we need to prove if this is span, if the set spans at matrix 2 by 2. Okay, we only have proven the first condition, so we need to continue with the second condition. So let's use the same metric, this matrix. One, 2, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1. Only now it will equal to A, B, C, D. Since this is not a square matrix, we cannot find the determinant. So we have to proceed to test if the answer is, if the solution is consistent or not. Okay, same like before. First, let's change this entry, the third row, R1 minus R3. And then let's also change this entry, so R4, R1 minus R4. From there we get 1 to 1, 0, 1, 0, 0, 1, 1, 0, 1, 1, 0 to 0. Okay. Third row C, R1 minus R3, so A minus C. A minus C, and then for the fourth row, R1 minus R4, so A minus D. A and B remains. Okay, continue. This time, we want to change R1 because this entry, change R1 minus R4, and then we also want to change this entry. So we want to change R3, row 3, R3 minus R2. Okay, R1. So 1, 0, 1. R2 is the same, 0, 1, 0. Okay, change R3, we get 0, 0, 1, and R4 remains. Okay. R1. Okay, we change R1. R1 minus R4. So A minus A minus D. A minus A minus D. A minus A. So negative minus negative D. D. Okay, we did not change R2. So B. We change R3. R3 minus R2. R3 minus R2. So A minus C minus B. And then we did not change R4. Still A minus D. Continue. This time let's change this entry. So what we do is we change R4. R4 minus 2 R2. 1, 0, 1, 0, 1, 0, 0, 0, 1. Okay, we only change R4. 0. Okay. 0, 0, 0. Okay, 0 minus 0 is 0. 2 minus 2 is 0. 0 minus 0 is 0. D, B, A minus C minus B. Okay, R4 minus 2 2 R2. R4 minus 2 R2. So A minus D minus 2B. Okay, from the last line, we can see that the statement is false. Because on the left, all the entries are 0. On the left, all the entries are 0. However, we still have equation on the right. Okay, so it is not consistent. Not consistent. Therefore, S. I believe the set is S. Let's check. K. K did not span at matrix 2 by 2. Therefore, K does not form a basis of matrix 2 by 2. Okay, even though earlier we checked that the set is linearly independent, however, the set is not spanned at matrix 2 by 2, so our conclusion, K does not form a basis of matrix 2 by 2. Okay, we have one more question to discuss. This time for vector. So we are given 3 vectors and we want to determine whether the set is linearly independent, okay, and if it forms the basis. Even though the question only asks for linearly independent, but to prove basis, we need to also test for spanning set. Okay, let's solve the last question. Multiply scalar by the vectors given. So C1 multiply by the first vector 1, 0, 1 plus C2 multiply by 2, 1, 2 plus C3 multiply by 0, 1, 2. And to test for linearly independent, this should equal to 0, 0, 0. Okay, to check, let's change this into equation. So C1 plus 2C2, and we don't have C3, so equal 0 because 0. and then 0, 1, 1. So C2 plus C3 equals 0, and then the last one we have 2C1 plus 2C2 plus 2C3 equal to 0. Okay, let's change into matrix form. So 1, 2, 0, 0. Okay, we don't have C1, so 0, 1, 1, 2, 2, 2. Okay, since this is a square matrix, 3 by 3, we can proceed by finding the determinant. Okay, I will choose again the first row. And the signs are positive, negative, positive. Okay, plus 1, so 1. Multiply by, okay, 1. Eliminate the first row, 1, 1, 2, 2. 1, 1, 2, 2. And then minus 0 plus 2. Okay, we don't have to multiply the 0 by any matrix because it will still equal to 0. Okay, plus 2, 2. Eliminate the last row, so we take 2, 0, 1, 1. 2, 0, 1, 1. Let's proceed to solve. 1 multiply 2, 2, minus 2 multiply 1. Okay, plus 2. 2 multiply 1, 1 multiply 0. 2 multiply 2 is 2 minus 2, 0. 2 multiplied by 2 is 4, not equal to 0. When determinant does not equal to 0, then the set, okay, let's check the name of the set. Oh, tak ada, kita letak dia V lah. The set is linearly independent and also span at R3. So the set form a basis of R3.